Hello everybody and welcome to this video. In this video I'm going to show you how a formative measurement model is evaluated using a smart PLS. So let's have a look at the characteristics of formative measurement models. Basically there are 4 points that you need to consider. The first point is that the causality in a formative measurement model is from the indicators or the items to the latent variable. The second point is that all of the values that you see over these arrows running from the indicators to the latent variable are called regression weights. Number 3 is that the indicators of a formative measurement model are not interchangeable, and in other words, each indicator of a formative construct captures a specific aspect of the construct's domain. And number 4 is that the items of a formative measurement model are expected to be lowly correlated. Alright, in this slide I have provided you with the procedure for evaluating formative measurement models, and basically these steps come from our article which was published in Higher Education. That is one of the most well-known journals in the area of higher education, and in case you would like to have a look at our article, you can simply have access to the article using this link. By the way, the first step is to evaluate formative indicators collinearity, and basically to do this we have to focus on the VIF values or variance inflation factors for any of the items of our formative measurement model, and we would like to see these values to be less than 5 or ideally less than 3, and if this is the case then it means that we have no problems with respect to collinearity among the indicators of the formative measurement model. Number 2 is conversion validity, and basically when it comes to conversion validity assessment for a formative measurement model, what you need to do is to run a redundancy analysis, and in doing so you need to specify a model with 2 components. One of them will be a formative construct and the other one will be a reflective construct, or preferably a single item construct, and both of these have to measure the same concept. And then if the path coefficient between these 2 constructs is greater than 0.7, it means that you have established conversion validity for your formative construct of interest. And then the third step is to test the indicator weight significance and relevance, and what you need to do here is that each weight expresses the relative contribution of the item to the construct, and each loading shows the absolute contribution. So both weights and loadings are important for a formative measurement model. Also note that the significance of the indicator's weights are assessed using a two-tailed percentile with a strapping test. So make sure that you select a two-tailed test. Make sure that you select a percentile with the strapping, and then do the analysis. And with respect to the results of this significance testing, what is important is that if the weight of one indicator is significant, the indicator can simply be retained in the model, and in case that the weight is not significant, what you need to do, you have to focus on the loading of that particular indicator, and if the loading of that indicator is above 0.5, although its weight is not significant, still you can retain it in your model. And the last point is a robustness check. So you can consider a robustness check for your formative measurement model, and basically this can be done using a CTA PLS analysis, which is a technique to empirically substantiate measurement models specification. This is something that I'm not demonstrating in this video, and possibly in another video I will show you how it can be done, but basically it's a very simple test. Alright, now let me just show you in more details what a redundancy analysis is. As I just mentioned, what you need to do is to specify a model with 2 components. So you would see that I have 2 constructs in this model. Both are the same concepts. Both of them are conceptual skills. Here conceptual skills has been measured with using 4 formative indicators, and Here we have conceptual skills being measured using just a global item. And if you specify this model, and if you estimate this model and see that the pass coefficient between these two constructs is above 0.7, it means that this construct, this conceptual skills formative construct has convergent validity. So this is how you need to do the redundancy analysis. And here also I have provided you with the details of assessing the significance and the relevance of the items of a formative measurement model. So remember, you have to run a two-tailed bootstrapping test for the weights of the items. If the weight is significant, then you can simply retain the item in your formative measurement model, and in case that the weight of the item is not significant, what you need to do is to check the loading of that item. If the loading of the item is above 0.5, you can retain it, and if it is less than 0.5, you have to delete the item from your model. Alright, it was all about formative measurement model evaluation. Now let's go to our model, and I'm going to show you how all of these can be done. Okay, so this is our model. You would see that I have conceptual skills here, which is a formative measurement model with 4 items. So the first step is to evaluate the collinearity among the 4 items of conceptual skills. So to get the VIF values for any of these 4 items, what I need to do is to run the model and just click on this link here, collinearity statistics. And when I click on this link, I will be provided with a panel with 2 tabs. One of them is outer VIF values and the other one is inner VIF values. Basically, inner VIF values is related to the to the constructs in my model, and for right now I'm just interested in the VIF values in my formative measurement model. And you would see that the items of all of the items have been listed here, but for me only the 4 items of my formative measurement model are important. So you would see that I have the VIF value for CS1, which is 1.361. I have the VIF value for CS2, which is 1.979. For CS3 I have 1.6, and for CS4 I have 1.899. So you would see that all of these 4 statistics here are less than 3, which means that collinearity among the items is not a problem in my analysis. And I can simply copy this information into an Excel file so that I will be able to prepare a report for my analysis. So I just paste the information here. Note that I only need the VIF values for my for the items of my formative construct. So I delete the rest, and now here you could see the VIF values for the items of communication skills. Alright, now let's go back to our model. The second thing that I need to analyze or to consider is to assess the convergent validity of communication skills. And remember, we have to do this using a redundancy analysis. So to do the redundancy analysis, I have to specify a model with 2 components, communication skills as a formative construct and communication skills as a single item construct. So let me just create a new pass model in this project, in my project, which is project A. So I just click on this button. Where is it? Oh, it's here. Okay, so redundancy analysis. Alright. Now you would see that a pass model has been created here under project A. So what I need to do is to add the formative items for communication skills. And let me just change it into a formative construct. And note that in my data set I have communication skills being measured using a global item. So CS underline G is just one item to provide measurement for communication skills. So this will be my single item construct, and what I need to do is to link these two components with each other, and then I can simply run this model. Alright, now let's have a look at the results. So here you would see that the pass coefficient between communication skills as a formative measurement model and communication skills as a single item construct is 0.778. Now if we look at our guideline here, you would see that basically when this value is above 0.7, it means that we have established conversion validity for our formative construct. So in terms of the second step, we have no problem regarding our formative measurement model. Alright, so let's go back to our model. I just close this and I also save it. I don't need this anymore. You only need to report the fact that you have done the redundancy analysis and the pass coefficient between the communication skills as a formative construct and communication skills as a single item construct was above 0.7, and perhaps you just need to report the exact statistic, the exact pass coefficient between these two constructs. Alright, now the third step is to check the significance and relevance of the items for my formative measurement model. And it's very simple. What I need to do is to run a bootstrapping test. So I just I just click on calculate button and then I select bootstrapping. Note that we have to consider 10,000 subsamples. You don't need to consider complete bootstrapping. Remember, for reflective measurement model evaluation, when you would like to generate the confidence intervals for all of those reliability and validity estimates, you need to select this option. But for formative measurement models, just the basic bootstrapping procedure will do, and there is no problem, and there is no need to consider this second option. Also note that you have to consider percentile bootstrap, and here I have to consider a two-tailed test at significance level of 5%. So 10,000 subsamples, basic bootstrapping, percentile bootstrap test, a two-tailed test at 5% of significance level. Now I'm done, and I can simply start the calculation to generate the results for my formative measurement model. Okay, so this is the results report for my bootstrapping test, and the first thing that I would like to check is to check the significance of the weights of my formative indicators. So if I click on outer weights, I will be able to see the results of the bootstrapping test with respect to the items here, the weights of the items. And basically I'm only interested in this area from CS1 to CS4. So only this area is important for me. And by the way, you would see that here I have some information like the original sample statistic, which simply means that this is the statistic based on my sample data. I have the sample mean, which is based on the bootstrapping procedure, the standard deviation, and also the t-test and the p-value. And if you just look at the p-values for CS2, CS3, and CS4, you could see that all of them are less than 0.05, which means that the weights for CS2, CS3, and CS4 is significant. And in other words, I don't really need to delete any of these items from my formative measurement model. But how about CS1? You would see that here the p-value is above 0.05. So shall I delete this from my formative measurement model? The answer is no. I have to check the loading for CS1. If the loading of CS1 is above 0.5, I can simply retain this item even though its weight is not significant. So let's have a look at the loading of CS1. To check the loading of CS1, I can simply click on outer loading, and here I have, in this row, I have the loadings for, I have some information, but the first piece of information here is the loading of CS1. And as you can see, the loading of CS1 is 0.544, and it means that basically this value is above 0.5, and in other words, although it's the weight of this item is not significant, but I don't need to delete the item from my formative measurement model because as I mentioned, the loading is above 0.5. So in the next step, what I need to do is to just copy this information. Let's just copy the information related to the weights into an Excel file. So I just copy the information here, and I just click on the tab, on this tab, confidence intervals, because I also would like to report the confidence intervals that are displayed in this tab. So I just click on Excel format again. I go to my Excel file and paste the information here. And what I need to keep here is just the information related to CS1 to CS4. And I have sample original sample statistic and also the sample mean statistic here. So I also have the information here. So I just delete these two columns. I also have the items here in this column. That's why I select these three, and also I just delete this one as well. So here you would see that I have some good information about the items of my formative measurement model. Again, there are some other information that basically you really don't need to report them, like the sample mean based on the bootstrapping procedure as well as the standard deviation. So allow me to delete that as well. And here I have the T statistic for the weights of the items. I have the p-values. I have the, and also I have the 95% confidence interval. And you know, when you want to report the significance of the weights, basically you can just resort to T statistic or p-value or the confidence intervals, and you really don't need to report all of them, but basically it's just you have to make a decision, or sometimes based on the comments from the reviewers, you have to make a decision which type of a statistic you need to report for your for the results of testing the significance of the weights of these formative measurement models. And the last piece of information that I have to add here is the loadings of these 4 items. So let me just go to my Smart PLS here. This time I click on outer loadings and I just click on Excel format, and then I come here and paste the information here. And again, here I have the loadings of my 4 items, CS1, CS2, CS3, and CS4. I can simply drag and drop this information here, and here I can just write loading. And so here you would see that, by the way, these items are will be retained in my formative measurement model because the weight of these items is significant. Here, based on p-value, based on this p-value, the weight of the item is not significant. However, because the loading is above 0.5, still I can keep this information. I have created a better, or somehow a more cleaner table to report the results. So let me just show you a better version of this table. Here you can simply see that I have created a table for the VIF values of all of those 4 items. I have added one statement to my results report info, or maybe my article, that based on the results of the redundancy analysis, I have managed to establish conversion validity for communication skills. So this is how you have to report it, and this is a table for reporting the results of the bootstrapping test for the items of the conceptual of the communication skills as a formative measurement model. Make sure that you add a note for your table and you mention this statement that the confidence intervals that have been reported here are based on a two-tailed percentile bootstrapping test based on 10,000 subsamples at 5% significance level. This is how you can simply create a professional and very transparent report, and basically you can just add this information into your article or into your thesis. Alright, thank you very much for watching this video, and I hope this has been of some use for all of you. All the very best and bye.